Folks, this is just a quick review. Okay, this is something you learned in college algebra. You probably did it again in a trig class. Okay, this is just a quick review. Here are your steps to finding inverses. So let's jump over to the next page and practice it. So here I've got a function. F of x is 2 plus e to the x minus 3. F of x is equal to 2 plus e to the x minus 3. Let's find its inverse. Well, don't go looking for a needle in a haystack unless you know it's there. If we're going to find an inverse, we better know that this function's invertible. How would we know if it's invertible? It's 1 to 1. Is it? F is 1 to 1. So we can it makes sense to ask what is its inverse. Okay. All right, so we know that this function's 1 to 1. So now what do? Well, this is kind of a gimmicky trick. You don't actually have to do this step. But I said go ahead and replace f of x with y. So we say y is equal to 2 plus e to the x minus 3. Okay. What's the next step in finding an inverse? Yeah, we swap the x and y. This is just kind of a little gimmick. It works. What we're really doing is we're changing the input with the output, which is that domain range switching there. The 2 plus e to the y minus 3. And now we're going to solve this expression for y. Okay? So we need to get y by itself. Well, where is y? It's in an exponential function, right? Y is a part of an exponential function. We need to get it by itself. So let's isolate the exponential. So that gives us that x minus 2 is equal to this exponential term, y minus 3. So now I've just got a single exponential term. So we can rewrite this exponential equation as its equivalent logarithmic equation, right? Or put it another way, we can take the natural log of both sides, right? However you want to look at it. So this gives us the natural log of x minus 2 is equal to y minus 3. Getting close. Getting close. Add 3 to both sides. So that gives us y is equal to the natural log of x minus 2 plus 3. And then, because that putting the y there was just to make the manipulation a little easier, let's actually relabel this as f inverse of x. Okay. Questions on that? Okay, so let's talk about the domain and range. The domain of f, what was I allowed to plug into my original function? Allowed to plug into that function. Yeah, anything, right? What could I exponentiate? What could I put over e? Any number I want. Okay, what could I subtract 3 from? Any number I want. What could I add 2 to? Any number I want. The domain of this function is all real numbers. Okay. Automatically then, what do I know the range of f inverse to be? Exactly. That is that domain range flip-flop. This has to be true. By construction of the inverse. How did we find inverse values? We took the, well, yeah, let's just stop there. We'll say a little more when we get to the next slide. Okay, so what question do I more commonly ask you to give me for a function, the domain or the range? The domain. I do that for 2 reasons. One, domain is just interesting in its own right. But 2, it is hard to find range. The question of what am I allowed to plug into a function is a lot easier to answer than what comes out when I plug anything into a function. That's a lot harder to answer. The range questions are harder to answer. Okay? Well, let's pause then. Let's hold off on finding the range of f. What is the domain of f inverse? We can answer that question by just looking at what we've determined f inverse to be. F inverse is a logarithmic function. Okay, so got to be careful here. Cannot take the log of a, excuse me, I shouldn't say that. I can only take the log of a positive number. Can I take the log of 0? No. No. Okay, so what is the domain of this function? Not 0 to infinity, careful. I can't plug in a 0 for x.
Greater than 2 to infinity?
Yeah, from 2 to infinity, non-inclusive of the 2. But what does that mean in terms of the range of the original function? It's also 2 to infinity. Okay? Domain range, flip-flop. How are we doing? All right, I'm not going to worry about sketching them.